Let's talk about building the perfect computer system. And I mean really perfect. What if it wasn't just powerful, but also rock-solid stable, unbelievably efficient, and you could rebuild the whole thing from scratch with just one command? Well, today, we're going to dive into a real-world blueprint for exactly that. It's an amazing NixOS configuration that shows what happens when you stop fixing your computer and you start designing it.
You know the feeling, right? You spend months, maybe even years, tweaking your setup until it's just so. The right tools, the perfect theme, everything's humming along. And then, the dreaded system update. You just kind of hold your breath, you hit enter, and you hope that this isn't the one that breaks everything. But what if all that anxiety, all that fear, was just gone?
The reason our systems feel so fragile is baked into how they're built. Most operating systems, they follow an imperative model. Basically, you tell it what to do, step by step. Install this, update that. And each command changes the whole system. An update overwrites some old file, a new library puts every other program at risk. It's kind of like building a skyscraper without a blueprint. You just keep adding floors and praying the foundation doesn't crack. And this leads to all the classic headaches we know and love. You get destructive updates, the infamous DLL hell, or one app needs the new library, but another one needs the old one, and they just can't play nice. Rolling back a change? Oh man, that's a nightmare. It's usually a manual, super risky process. And upgrades aren't atomic, which is a fancy way of saying a power outage mid-update can leave your system totally bricked. And maybe worst of all, your setup is never, ever truly reproducible. Okay, but there is a totally different way to do this. Enter NixOS. And look, this isn't just another Linux distro. It's a whole new way of thinking. Instead of that step-by-step imperative model, it uses a declarative one. You don't tell your computer how to do things, you just describe the final system you want, and NixOS figures out how to build it perfectly, every single time. And this is the core idea that just changes everything. Your entire system. I'm talking the kernel, your apps, user accounts, the whole shebang. It's all defined in one single configuration file. This file becomes the master blueprint. It's the one source of truth for your entire machine. So how on earth does this actually work? Well, it's pretty ingenious. Every single package gets stored in its own, totally isolated folder inside something called the Nix store. The path to that folder is a unique hash of all its inputs. That includes all of its dependencies. If you change even one tiny thing, like a compiler flag, boom, it gets a brand new, separate home. Nothing ever gets overwritten, which means that whole DLL hall problem is just not a thing anymore. It's gone. This total isolation makes one of the coolest features possible: atomic upgrades. When you go to update your system, Nix builds the entire new version in the background. It's only after that build is 100% successful that it flips a switch and makes it the active one. If anything goes wrong, the build fails, your power goes out, your current working system is completely untouched. It is physically impossible for a failed update to break your machine. And the payoff for all this is just huge. Since the old versions are never deleted, every time you successfully build your system, you create a new generation. And that means all your previous setups are saved and waiting for you right there in the boot menu. So if an update gives you a weird bug, you don't have to troubleshoot. You just reboot, pick the last generation from the list, and you are instantly back to a perfectly working computer. So that's all the theory. It's pretty cool, but let's see what it looks like in the real world with an absolutely masterclass example. This is a NixOS configuration built by DeMoD LLC. It's for some seriously demanding R&D work, and it's running on the Framework 16 laptop. It's a perfect showcase of what you can do when you really lean into this declarative model. Right, so this whole configuration is specifically designed for that awesome modular Framework 16. Its main job is to be a stable, powerful environment for developing the DeMoD communication framework. It's running a super lightweight desktop called Hyperland, which is already very fast. But the really astonishing part, the feature that proves just how powerful this approach is its efficiency. This system is designed to hit 0% CPU usage when it's just sitting there, idle. 0% idle. Just think about your own computer for a second. On a modern laptop with a full graphical interface and all your stuff running, that number seems completely impossible. But it's not a gimmick. It is the direct result of a meticulously crafted configuration where every single piece of software is chosen on purpose and tuned for peak efficiency. There it is. That's the magic number. Even with development tools and network analyzers installed, the system can just sit there, sipping virtually no power. And what that means for you is incredible battery life.
a machine that runs cool and silent, and the peace of mind knowing that there are no rogue processes eating up your resources in the background. This is what total control over your system actually looks like.
So how they do it? Well, it comes down to a three-part strategy, and it's all defined right in that one config file. First, smart power management. There's a background service that's constantly adjusting the CPU frequency, scaling it way down when it's not needed. Second, a super lightweight UI. Hyperland is a minimal desktop that doesn't have a lot of heavy stuff running in the background. And finally, automated cleanup. The config actually schedules a weekly garbage collection to clear out old, unused system files and prevent bloat.
That level of efficiency is just amazing. But the true power here, the real game changer, might be something else. The fact that this entire, highly optimized system is perfectly reproducible by anyone.
A lot of us try to solve this problem with setup scripts, but let's be honest, it's a fragile fix. A script is just a list of commands, and those commands can easily break as packages change over the months. And if a script fails halfway through, you're left with a broken mess. A Nix configuration, though, is the system definition. It can't become outdated. And like we saw, because it's atomic, it's impossible for it to fail and leave you with a broken install. And look, here's the crucial point, summed up perfectly by Reddit user NoBrains101, who said, "My entire config and computer setup is restorable in literally one command straight from GitHub." Just imagine that for a second. You get a brand new laptop, you run one command that points to your config file, and you just sit back and watch as your entire perfectly optimized environment builds itself from scratch. That's the ultimate disaster recovery plan. The DeMoD config is a fantastic blueprint for a high-end R&D machine, but its core ideas, declarative design, atomicity, reproducibility, they apply to everyone. It proves that you don't have to choose between a powerful setup and a stable one anymore. You really can have both, which, it leaves us with one final thought. If you had this kind of power, what would you build?